We're going to go on and start going over the review sheet today. We will finish it tomorrow. Now, the first thing we're going to look at is these three problems here, 1, 2, and 3. For these three problems here, we want to state the degree and leading coefficient. Thank you. And if we look at problem number 1, the degree is the exponent, goes with the exponent with the biggest variable. And the exponent with the biggest variable, or the variable with the biggest exponent, is x to the 8. So it tells us the degree of this function here is 8. The leading coefficient is the number in front of the variable with the biggest exponent, which is negative 27. So for the first one here, the degree is 8. The leading coefficient is negative 27. Question on the first one here. Now it's not going to be 7 because it's not just the first term. This one here is just not written in standard order. So it'd be this one here. If we look at number 2, the degree would be what? 4, because the biggest exponent is 4. Leading coefficient, the number in front of the variable with the biggest exponent is 6, because our x to the 4th gives us the degree. Number in front of it is the leading coefficient. Well, might as well go on and do number 3. What's the degree for 3? Yeah. Variable with the biggest exponent, x to the 7th. So the degree is 7. Leading coefficient is negative 27, because we have to take the sign in front of it. It's just coincidence that the leading coefficient for 1 and 3 are the same. Any questions on 1 through 3? Let's look at 4 through 7. Evaluate each function for the value of x. Which one of these do we want to look at? Take a pick. 6. Whenever we evaluate any of these here, we're just replacing each x with its value. So we'd have 8 to the 6 minus 64 times 8 to the 4th plus 8 squared minus 7 times 8 minus 51. Now at this point here, we can plug the whole thing into the calculator. So we can say 8 to the 6th minus 64 times 8 to the 4th plus 8 squared minus 7 times 8 minus 51. When we type it all in and hit enter, we get negative 43.
We just add 8 into the...
We replace every x with 8. Yep. I mean, we can go on and do number 7, so it would be 5 times negative 12 to the 3rd minus 3 times negative 12 squared plus 2 times negative 12 plus 4. So replacing every x in the equation with negative 12. So we'd have 5 parentheses negative 12 to the 3rd minus 3 times negative 12 squared plus 2 times negative 12 plus 4, which is negative 9,092. Questions on 1 through 7? We go with problems 1 through 7. Yes? We good with these here? We ready for the next ones? Problems 8 through 10. Determine if the following function is a polynomial function. Well, there's a few things that we had to know to be able to determine if they are. Exponents can't be negative. Exponents cannot be fractional. Exponents aren't variables, so the exponent cannot be a negative number, a fraction, or have a variable in it. Variables aren't inside radicals, so we can't have the square root, cubed root, fourth root of x. X cannot be inside of a radical. We can't have two different variables being multiplied together, x times y, and variables cannot be in the bottom of a fraction. So if we look at number 8, is number 8 a polynomial function? Yes or no? Because? You gotta have a reason. So if it fails any of these here, exponents cannot be what? They cannot be? Exponents aren't negative. They are not variables. Variables are not inside a radical. We can't have square root of x, cubed root of x. We cannot have x inside of a radical. We cannot have variables multiplied together, and variables cannot be in the bottom of a fraction. We can't have 1 over x or anything where x is in the bottom of the fraction. So number 8, is it a polynomial function? Because no, we can't have a negative exponent. How about number 9? So do we have any negative exponents? Do we have any exponents that are fractional? Do we have any variable in a radical? Do we have two different variables being multiplied together? Do we have a variable in the bottom of a fraction? So is this a polynomial function? Yes. How about number 10? Because it is not one, because our x to the 1/2. So if it doesn't have fractional exponents, negative exponents, variables in an exponent, all that's really attached to the variable itself. We cannot have a variable inside of a radical or the bottom of a fraction or two different variables being multiplied together. If it doesn't have any of that, it is a polynomial function, like number 9. Questions on 1 through 10? Questions on any of these here? Remember that? Questions on 11 or 12, or one of these that you want to see worked? 12. Here we're adding two polynomial expressions together, so when we're doing addition, we can go on and remove our parentheses first. And after we do that, we're going to combine like terms. We always start with the variable with the biggest exponent. And for us here, incidentally, it is the first term, our 12x to the 5th. Are there any other terms with x to the 5th? Any like terms with it? Well, no, it's the only term that has x to the 5th. If we're decreasing in power, the next one after would be x to the 4th. Well, we do have two of them. We have negative 3x to the 4th plus 8x to the 4th. Negative 3 plus 8, or 8 minus 3, is positive 5. 8 minus 3 is 5, so we have 5x to the 4th. Because when we add or subtract like terms, the variable will stay the same. We're just adding or subtracting the numbers in front of it. After the 4th would be cubed. Well, there's only one x to the 3rd term. So we just say minus 3x cubed. The term after that would be our x squared term. Is there an x squared term anywhere in this? No. So we move on to just x. 2x plus 4x is plus 6x. And lastly, negative 5 plus 1 is -4. And that's it. Questions on this here? Questions on number 12? And combine like terms. Because we're combining like terms. That's it? Yes. Questions on number 12? Questions on 13 or 14? Similar, but this time we're subtracting. And we're looking at subtraction. We can drop the parentheses for the first term. We don't need them. But our second set of parentheses, the one we're subtracting from the first, we have to distribute that negative, which takes our positive 2x to the fourth and turns it into a negative 2x to the fourth. Our positive 3x cubed becomes negative 3x cubed. Our negative x squared becomes positive x squared. Our positive x becomes negative, and our negative 4 becomes positive. We have to change the sign of everything in the second set of parentheses because we're subtracting it. And now we combine our like terms. Do the same as what we did for the problem before. X to the fourth is the biggest term, so it's going to go first. 7x to the fourth minus 2x to the fourth. 7 minus 2 is 5x to the fourth. Negative 9x cubed minus 3x cubed. Negative 9 minus 3 is negative 12 x to the third. Negative 4x squared plus x squared, negative 4 plus 1 is negative 3, and we still have our x squared. Move on to our x terms. 5x minus x. 5 minus 1 is plus 4x. And lastly, 6 plus 4 is plus 10. Our subtraction is very similar to our addition. We just have to distribute that negative and then combine like terms. Questions on this here? Questions on number 14? Friday. Questions on 15? 15 or 16? 16. When we multiply two polynomial expressions, the first thing we're going to do is distribute our first term. So for this one here, the first thing we're going to do is multiply everything by 2x. Our 2x times 2x squared, our 2 times 2 is 4. X times x squared is x to the third, because when we multiply like bases, we add the exponents. So our 2 times 2, we can multiply and get 4. X times x squared gives us x to the third. 2x times 5x, our 2 times 5 gives us positive 10. Our x times x gives us x squared. And lastly, 2x times 8, our 2 times 8 gives us plus 16. And we still have our x. Now we'll do the same thing with 4. 4 times our 2x squared, 4 times 2 is going to be 8. X squared, our 4 times 5x, 4 times 5 is going to be 20. We still have the x. And lastly, 4 times 8 is going to be plus 32. Questions on this here? Now at this point here, we're going to combine like terms. 4x to the third does not have any like terms, so it just stays 4x to the third. Our 10x squared and 8x squared are like terms. 10x squared plus 8x squared is 18 x squared. Our next step is going to be 16x plus 20x, and 16 plus 20 is 36, and we still have our x. And lastly, we have plus 32, and it doesn't have any like terms, so we get this here. Any other questions on 16? Questions on 15, 16, or 17 before we move on to 18 and 19? Let's see here. 15 would be similar, but we don't have to do it twice. We're just going to multiply it once. Because 6x cubed times our 2x squared, well, 6 times 2 is 12. And our x cubed times x squared would be x to the 5th. 6x cubed times negative 27, well, we can do 6 times negative 27 in the calculator. It'll tell us it's 162, negative 162. And our x cubed times x is x to the 4th. And we could have been doing the number multiplications. We could have done 6 times 2 in the calculator, and it would have told us it's 12. 6 times negative 20 is negative 162. And lastly, we can do 6 times 4, which is going to tell us it's positive 24. And we still have our x to the 3rd. Because unless we're evaluating for a specific variable, we can't plug x into either calculator because the calculator needs a value for it. Questions on 15, 16, or 17? Questions on 18 or 19? 19. Whenever we multiply 2 or more sets of parentheses together, we just got to multiply 2 of them together first, simplify, and then multiply the other one with it. So we'll multiply these 2 together first. So the first thing we'll do is distribute our x. X times 3x is 3x squared. X times 1 is going to be plus x. Negative 2 times 3x is negative 6x. And negative 2 times 1 is negative 2. Now, before we start multiplying again, we do need to combine any like terms. And our x and negative 6x are like terms, and x minus 6x is negative 5x. And now at this point here, we repeat the process. We'll do 3x squared times 4x, which will give us 12x cubed. 3x squared times negative 3 would be negative 9x squared. Then we'll distribute the negative 5x. Our negative 5x times 4x is negative 20x squared. And negative 5x times negative 3 is plus 15x. And lastly, negative 2. Negative 2 times 4x is negative 8x. And negative 2 times negative 3 is plus 6. And last but not least, we need to combine our like terms. And luckily for this one here, they put the like terms ended up being next to each other. Negative 9x squared minus 20x squared is negative 29x squared. 15x minus 8x is plus 7x. And then we have our constant term, 6. So we get this here. Questions on any of this here so far? All right. The next thing we're going to look at is division. Now, whenever we have a two-term thing that we're dividing by, we can divide this with synthetic division. So we would set it equal to 0 and then get x by itself. At this point here, we would add 5 to both sides. Minus x is equal to 5. Questions on how we got this started? After finished solving for x, we put that number in the cubby, and then we take the numbers in front of the variables and the constant term and put them across the top. If there are any missing, we fill them in as 0. we bring the first number down. We'd have 1 from our x cubed, negative 10 from our x squared, 20 from x, and 26. Now at this point here, we multiply. So we do our 5 times our 1, which is 5, and we put it under our next number. Then we add straight down. Negative 10 plus 5 is negative 5. Then we multiply again. 5 times negative 5 is negative 25. 20 plus negative 25 is negative 5. Then 5 times negative 5 is negative 25. And lastly, we add 26 and negative 25. This time we'll get positive 1. And again, we could do these in the calculator, not the whole thing, but each part of the calculations, because we can do 5 times 1 in the calculator. Gets us 5, we'll put it under the negative 10. We can then add those two together, negative 10 plus 5, and get negative 5. Do our multiplication again, add, multiply, and get this here. Now the next part is to put our variables back in and then rewrite this back out, because our 1 in the box is the remainder. The number next to it, negative 5, is our term without x. The next negative 5 is our term with x, and 1 is our term with x squared. So our final answer for this here is x squared minus 5x minus 5 plus 1 over what we're dividing by. We come back to the top, and we were dividing by x minus 5. So x squared minus 5x minus 5 plus 1 over x minus 5 is our final answer. Questions on this here? Questions on 21 or 22? Either one of those that y'all want to see worked. We good with 21 and 22? Let's look at 23. 23 can be done in one of two ways. The first main way, we'll do this one by long division. So we have this here. So we're going to do this one by long division. We'll do 24 by synthetic. Just 23 and 24 can be done either way. Some find it a little bit easier to do this with long division than synthetic division. Now the first step in long division is to see what times x squared will give us 2x to the fourth, because we need to cancel that first term out. But we do know that we'll need a 1, or not 1, 2, to make the 1 in front of x squared to be 2. And to turn x squared and x to the fourth, here we have 2x's, here we have 4, so since we're missing 2, we're going to need to multiply it by 2x squared. So at this point here, we're going to take 2x squared and multiply by our x squared plus 4x minus 2. And we're going to distribute this here. 2x squared times our x squared is 2x to the fourth. Our 2x squared times 4x, 2 times 4 is going to be plus 8. And our x squared times x is x to the third. And lastly, 2x squared times negative 2. 2 times negative 2 would be negative 4. And we still have our x squared. At this point here, we put this underneath what we're being divided, underneath our division bar. Now at this point here, we subtract. And the first one we're subtracting is 2x to the fourth minus 2x to the fourth. At this point here, these two cancel. Then we do our next one, negative x to the third, or 8x to the third minus 8x to the third. Incidentally, that also becomes 0. Our next one, negative 5x squared minus negative 4x squared. Negative 5 minus negative 4. We could do that in a calculator. Negative 5 minus negative 4 is negative 1. Or if we did this by hand, the negative and negative become plus. And negative 5 plus 4 is indeed negative 1x squared, or just x squared. And once we finish doing this, we bring down the next term. Questions on this so far? Now this one is a little interesting, mainly because at this point, what we're dividing this by has 3 terms. What we have down here only has 2. And since that's the case, we just need to bring another term down. Now at this point here, we need to see what times x squared gives us negative x squared. Well, we already have the x squareds. We need to multiply by 1, and since it is going from positive to negative, the 1 needs to be negative. So we're going to do negative 1 times our x squared plus 4x minus 2. Negative 1 times our x squared is negative x squared. Negative 1 times 4x is negative 4x. And negative 1 times negative 2 is going to give us plus 2. And again, we'll put it underneath. Negative x squared minus 4x plus 2. And again, just like with the previous one, at this point here, we're going to subtract. Negative x squared minus negative x squared is 0. Negative 4x minus negative 4x, incidentally, is also 0. And lastly, our 2 minus 2 is 0. So that's telling us the remainder is 0. And this up here is our final answer. So our answer for 23 is 2x squared minus 1. If we did have a remainder, we would add it onto the end just like we did with our synthetic division and put what we've been dividing this by underneath and the remainder on top. But if the remainder is 0, we don't include this here. Questions on 23. Questions on how we did this one here. We good with this here? All right. We're going to look at number 24. Now I'm going to change number 24 a bit. I want to change that from negative x cubed to positive. That will give us a different answer than what's on the answer key for the review sheet, because that answer is with it being negative, not positive. I'm going to also show you guys again how to do this with synthetic division, because it is possible to do these by synthetic division. You're not required to do those as part of the test. The bonus question is asking you to do one of these here by synthetic division, but it's not required. Now, if we're going to solve this by synthetic division, first thing we do is what we have to do is take what this is being divided by, our x cubed minus x plus 3, set it equal to 0, and then get our x squared term by itself. Now, there's one of two things we can do first. We can either add the x to both sides or subtract 3. Here I added x to both sides, and then the next step is I'm going to subtract 3. It doesn't matter which one we do first, because if we add x, we'll have to subtract 3 from both sides next. If we had subtracted 3 from both sides first, we would add x to both sides next. So no matter whichever one you do first, you'll end up getting to the same spot. We have to do both of them. It just doesn't matter which order we do them. Questions on this so far? Now the next step is to take the constant terms and our coefficients from this and put them in the cubby. Now we know the negative 3 because we're used to using it, but we do take the constant term with x, and it would be 1. So we'd have 1 and negative 3. Now the coefficients for what's being divided by, 3, 1, 8, 5, 3 go across the top. And again, if we were missing any terms, we'd have to fill it in with zeros. Our biggest variable exponent with a variable is 4. So we need our fourth power, third, second, first, and constant. And we do have them all. Another way to check is the number going across the top, not inside the cubby. Should be one more than the degree. Well, the degree is 4, so we should have 5 terms. 3, 1, 8, 5, and 3 is a total of 5 numbers, so they're all there. Questions on this here? First thing we do with this here is bring the 3, our first number, all the way to the bottom. Our next number goes down 1. Since we have 2 lines, the first number goes below the second number goes below the first. And now we can start our multiplication. Now when we multiply, our 1 and negative 3 will both be multiplied by the number under the second line. So we'll do 1 times 3. And all the numbers, our number on the bottom that's being multiplied by the first number will go above the second line. And our second number, here negative 3 times 3 is negative 9. The second number will go above the first line. At this point here, we add straight down. Our 1 plus 3 gives us 4. Our 8 plus negative 9 gives us negative 1. And we do this process again. So we're going to do 1 times 4, which gives us 4. Our negative 3 times 4 is negative 12. At this point here, we're going to add straight down. Negative 4, or negative 1 plus 4 is 3. 5 plus negative 12 is negative 7. Then we're going to do this again. We'll have 1 times 3, which is 3. Negative 3 times 3 is negative 9. And again, we're going to add straight down. Negative 7 plus 3 is negative 4. 3 plus negative 9 is negative 6. Now at this point here, we don't have another number on top to go on, so we're done. Now at this point here, we can bring the last number down, so we have them all in the same row. Now when we did synthetic previously, how many numbers did we have in the box? 1. And how many numbers did we have for our remainder? 1. Here, how many numbers do we have in the box? 2. So how many remainders should we have? 2. So the last 2 numbers are a part of our remainder, and the others are not. Now, a part of this remainder, the variables do apply. So the farthest to the right, the negative 6, would be the term without a variable. And here, the negative 4 would be the term with x. Outside the box, the first 3 is our term without x. Our 4 is our term with x, and our 3 is our term with x squared. So our final answer is 3x squared plus 4x plus 3 plus, we have to put the remainder on top of the fraction, negative 4x minus 6, over what we were dividing by. Our x squared minus x plus 3. So this here is our final answer. Questions on any of this here? Questions on anything we've done so far? Well, we'll finish this up tomorrow.